In problem number 2, let f of x given as 1 over x plus 2 and g of x equals 1 over x. First question is to write down the transformation which maps the graph of g of x to f of x. So may say from g of x, it becomes f of x. So 1 over x becomes 1 over x plus 2. So the transformation is horizontal. So if you're going to write it in matrix form, it's negative 2, 0, meaning to say there is a horizontal translation 2 units to the left. For letter B, hence or otherwise, write down the equations of the asymptotes of the f of x. So the asymptote or the vertical asymptote is equal to x equals uh, negative 2. This is by transforming this into the denominator, x plus 2 equals 0. So x equals negative 2. And since for the horizontal asymptote, our y equals 0. Letter C, find the inverse of x. So using the same method that we're using, we exchange y for x. So we'll have here x equals 1 over x plus 2. So we can cross multiply this. Xy plus 2x equals 1. And then we solve for y. We solve for y. We say we divide this by x. We divide this by x. So when we divide this by x, we're left with y, which is actually the inverse of x. So y equals 1 minus 2x over x. Or we can also write that as 1 over x minus 2. For the next problem, number 3, find the set of values for which there are two distinct real roots to the equation, to this log equation. When we say two distinct real roots, this refers to finding the um, what do you call this? The D or discriminant. So I already changed this since our log is base 2, the log here is base x. So we can use change base formula. So change base where I change base to 2. So log base x of a is the same as log base 2 of a over log base 2 of x. So cross multiplying, we have log base 2 of x squared plus 3 times log base 2 of x, and we're left with log base 2a. And then using the general formula, we have this. We use a general formula so we can find the discriminant b squared minus 4ac is greater than 0 because there are two distinct real roots. So it must be greater than 0. So b squared, this is our b, 3 squared is 9. Our a here is 1. So 4 times 1 minus our c is log base 2 of a must be greater than 0. So 9 minus 4 log base 2 is greater than 0. And then we can transfer 9 to the other side. And then we are left with this, which we can write in exponential notation. Um, our base is 2 raised to negative 2, 2.25 is the value of a. So our a must be the value of 2 to the negative 2.25 is 0.210 in three significant figures. So since we're looking for the set of values, it must be all numbers greater than 0.210. Okay, let's move on to the next. Uh, Number 4, a ball is dropped from a height of 5 meters. Each estimate each time a ball bounces, it reaches 85% of the height it reached on the previous bounce. So if we're going to picture that, say this is from 5 meters, it fell down, but it will not be reaching 5 meters again. Instead, only 0.85 of that. It bounce and then it goes down, and then when it goes up, it must be 0.85 of the previous, and so on and so forth. So we find the height only that the ball reaches the sixth bounce. We're not referring to the bouncing back and up and down. So the height it can reach on the sixth bounce. So we will be using the formula uh, 0.85 raised to 6 times 5. 6 bounds. So it will be at 1.89 meters. Sorry, I forgot the unit. And then the ball bounce k times before it no longer reaches a height of 2 meters. So 5, from a height of 5, it will not be getting 5 on the next bounce. It will be 0.85 of that. So it's getting smaller and smaller. So the question here is, on at what time, what will be the value of k, or the time where it can no longer reaches 2 meters. So we can use the formula for u sub n, and then we substitute. Let's say our u sub n is 2. 0.85 u sub 1, that's the first bounce of that, is 0.85 times 5, and then the next will be 0.85 k minus 1. Let's say k, or n, I'll just change n to k. Let's say k is the number of bounds minus 1. So using the formula, substituting the formula, we shall have this, and then we can divide with this number. So we are left with 0.85k minus 1, and then we can use our calculator to find the value of k, which is 5.63605. So is it 5 or 6? That's always the question. Then you can use your calculator to check whether it's 5 or 6. So in this case, on the sixth bounce, it can no longer make uh, 2 meters height. Now for letter C, find the total distance traveled by the ball. So when it bounces up, it needs to go down. So we are not just finding the sum of the up, but also sum of the down. That's why and the up and down are the same. So we shall have 2 uh, s of n plus 5. Why plus 5? Because we started from this height 5. It comes from here 5. And then, so from 5, and then here, and then here, something like that. So that's why it's 2. We get the summation of this, because if we only take the summation of up, it will be sub n, s sub n. But since it doubles up down, so we get the also we solve it twice. So first we solve for the formula of s sub n. Using this formula and substituting, we get this, and then we substitute for s sub n, then plus 5. So we'll have, in total, the ball traveled 40.3 meters.